So remember, we used the ideal gas law when we had a sample of gas just sitting there under one set of conditions. But what if we have a sample of gas that changes conditions? Let's say here we have a sample of gas that occupies 56.8 liters, that's a volume, at a pressure of 1.62 atmospheres, and it's compressed to 21.3 liters. How can we solve this problem? Because we don't have the number of moles and we don't have a temperature. Well, let's go back to the ideal gas law for a second. If we have the ideal gas law, remember, PV equals nRT, and R is a constant. So if I rearrange this equation, R is going to equal PV over NT. No matter what PV and NT are, they're always going to equal R. So before I change the gas, at those initial conditions, 56.8 liters and 1.62, if I knew the moles and the temperature, it would equal R. And after I make the change, it still equals R. So we can combine this into what we call the combined gas law. P1V1 over N1T1 equals P2V2 over N2T2, because they both equal R. So now we have this equation, combined gas law, which we're going to use when gas is at one condition and it changes to another condition. In other words, we know the information at one set of conditions and we want to know this information at a second set of conditions. We don't know N and T in this problem. Well, that means that N and T are not changing. So we can go ahead and use this equation in a slightly different form. If they're not changing, it drops out. So we have P1V1 equals, change the pen, P2V2. Now I can just put my numbers in there. So being very careful when you read the problem, here's the catch. Make sure you have the conditions that are the same. So here I have 1.62 atmospheres times 56.8 liters equals, well, I don't know the new pressure. That's what I'm looking for. P2 times my new volume, 21.3 liters. Now I simply have to solve. P2 equals 4.32 atmospheres. And so we've used the combined gas law to solve for a change of condition to find a new condition. Now we have a slight variation of the problem. First of all, why are we worried about changing conditions? Well, if I have a sample of gas at one set of conditions and I want to compare it to another sample of gas but a different set of conditions, it makes it difficult. So we have a set of conditions called STP, or standard temperature and pressure. Those are defined conditions just so that when we say STP, any chemist in the world will know those conditions. I don't need the numbers because I know the numbers in my head and you'll know the numbers in your head of STP. Standard temperature and pressure. Standard pressure is 1 atm, can't be easier than that. And standard temperature is 273.15 K. You recognize that? Oh wait, that's how we convert temperatures. So these are the conditions we're looking at. Now, let's look at our problem here. If a sample of a gas occupies 10.2 liters, there's my volume. At a temperature of 301 K, there is my temperature. And a pressure of 0.621 atmospheres, that's a 1. What volume, okay, I'm looking for volume. I'm looking for the new volume. Will it occupy at STP? Oh, STP, pressure of 1 atmosphere, temperature of 273.15 K. Now, let's put things into my combined gas law. In this case, what variable am I missing? Moles. So I can go ahead, P1V1 over T1 equals P2V2 over T2. Now I just got to plug my numbers in. Let's put them in. There's my numbers. I put them in there and I'm looking for the new volume. What volume? Now notice, it's pretty simple. Just got to do some math here. V2 is going to equal, let's see, I take 0.621 times 10.2 divided by 301 times 273.15 divided by 1 equals 5.74 liters. So what did we learn here? STP is a standard set of conditions, and I'm going to use the combined gas law when I have a sample of gas at one set of conditions and I'm changing it to a new set of conditions. Ideal gas law when a gas is just sitting there in front of me, combined gas law when it's changing.